So for those who don't know me, my name is Alexey. I live and work in Norway, and I'm in the DDD community for quite a while, and I wrote this book about event sourcing in domain design. Was published this year, but I'm here not to talk about what I wrote in the book, but it's like something else, stuff that I was experimenting with. Oh, it's fixed now. Awesome. Stuff that I've been experimenting with when I encountered some challenges in production event source systems. So I just want to do the audience check. So who knows about event sourcing and what it is, what it does? Oh, that's good. That's awesome, because I did it on Rock, and it's like 10% of the room. I need to explain that so we can save some time. And actor model, who knows about actor model? A lot of people. Oh, that's awesome. So, all right. The reason why I started to explore this connection is I got interested in this before, and I saw the book from Von Vernon, and I actually met him and asked him to talk about this here in Berlin, actually, in the DDD meetup. DDD community in Berlin organized a workshop a couple of years back. And then I met a couple of guys that were like really into actor model and saying aggregates and actors are a match made in heaven. So you basically do all your aggregates as actors, and then you're in heaven. So I don't really agree with that, and I will tell you why. But why I moved more to event sourcing? Because basically I was designing a system that runs on a pretty large scale. It's not incredibly large. It's not like Netflix. That is still some billions of messages per month, or maybe trillions in the future. And what we... Jesus Christ. It's coming again. All right. So, and the thing is, what we do in sort of in the systems that we call... Oh, that's not what I wanted to do. I think it got worse. So, this guy is not updated. All right. So, what we have in event source systems, like we do them now. So, say we have it's really disturbing, to be honest. So we have a user, or we have a system which is most probably oh, Jesus Christ. This is urgent, yeah. I'm really sorry about that. And what happens then is that never mind. So the command comes to something to our application, right? So this is our application boundary. And when it comes to the application, we have some sort of application servers, right? So I don't know how to draw it. Let's do. So the app service. And the app service processes the commands. How does it do it? Remember? In sort of classic DDD, I can call it classic now because it's like that. What does the application server do? Service. Okay, the answer, nevertheless. So I have usually in the command operates in one single aggregate, right? So the command gets the aggregate ID. Using this aggregate ID, the application service goes to the EventStore and reads the stream, right? So the stream is for a single aggregate. It reads the stream and to reproduce the state of the aggregate. So then the application service can decide what to do. So it actually calls the aggregate. And aggregate executes this command, or you call the method, and it stores an event, right? So at the end, you get an event. For the sake of Alberto Bernolini, I will use orange color. So this is the flow, right? And then when we actually need to show something on the screen, what we do is, of course, is that we have a projection, right? So we have probably it's in another place. I don't really care. So what we have is the projection. And the projection reads an event, comes here, and it updates the read model. So this read model over here. All right, so far so good. And we show the read model on the screen for the user, right? So when you go on scale, you have one significant issue. And this issue is performance of this operation. The performance of this operation. So if you have an aggregate, we keep the aggregate small, but still, if you have things like telemetry or you have financial updates and stuff like that, we can have a discussion how they want to put it into the aggregate or not. But that's another story. I'm talking about technical details. So this is a very technical discussion. So it will take time to read all these events to reproduce the current aggregate state. And well, writing an event takes literally a very small amount of time. If the stream is big, then it may take quite a lot of time to reproduce aggregate state every time. So there is a parallel world in event sourcing, which is our friends from the massive events data-driven systems, massive event processing. Like Martin Kleppmann wrote a book about it, so I don't know if some of you read it, but he actually talks about that. So they built event source system that never sort of recover any kind of state. They just keep a snapshot of a state every time in some kind of other storage. This induces some other issues. So for example, how would you rebuild your system? I mean, if your system is so massive, if it has billions of events in the EventStore, you probably will never do the replay or recovery because it just takes too much time. So I haven't found an answer for that question yet. So I invited a bunch of people from that community to the event sourcing event, part of the Domain-Driven Design Europe next year. So if you're interested, you can come over. It's one-day event. Awesome speakers, and almost half of them, or even more, are sort of not from the DDD bubble, as I call it, and they have some other ways of doing it. But let's say I want to stick with the DDD approach. So I want to have aggregates, and I want to have my transactional boundary, and I want to have the state to operate with, and this state needs to be reliable, because what we do here, in this place, over here, is we ensure the consistency, right? So we always need to know the state, the previous state, and we need to enforce the invariance. Can I execute this operation on this entity or not? Has entity become invalid after I executed the operation? This is also an invariant. So all of this you check based on the state, and the state is reproduced from events, so you read from the string. So I started to think how I can avoid doing that, and this actor model came in mind, because actor model basically is, for me, in that regard, in relation to event sourcing or DDD styled event sourcing, it's you have your aggregates running as sort of actors, but I don't really like that approach. But still the idea is the same. So actor is a stateful object. It can be stateless, of course, but usually it's stateful object. It keeps the state in memory. It can be persisted, and it runs as long as we need it to run. So let's have a look at some I have some traditional code, right? So I wrote a couple of services. This is not it, that's the one. So the code will be bigger, the thing. So let's say we have a domain. I mean, it's extremely simple, don't blame me for that. That's the domain, right? I might have something better. This one, for example, that's the vehicle. I use some sort of functional style, so all my methods, or my aggregate is actually a set of functions. Yeah, but it has a state, and the state is produced by events. So you can see that there are some handlers, like when it's overheated or something like that. So it has some methods, and every state can be reproduced from events. So basically, this is pretty typical. It might be a little bit confusing style because I haven't used sort of a normal object-oriented aggregates, but nevertheless, you can see that it just has apply methods. We usually have an EventStore system. Every event gets applied and it gets the state, or produces a new state. But what we do here in the command service, if I look at my thing is here. So the command service receives the command, and in the background, it actually retrieves the aggregate. So if I look at the command service code, you will see what it does is actually retrieves the aggregate entirely, and retrieving the aggregate involves reading the string. This is pretty typical. We can also call it like stereotypical architecture by now. I mean, 2 years back and 3 years back, it was pretty advanced. So yeah, I wasn't really liking it because I got a system that has tons of messages, tons of commands. You can say it's tons of events coming from another system that trigger commands, and like telemetry, for example. Usually you deal with tons of telemetry, millions and billions. It can be in the systems I worked on. It was like tens of thousands per second, and so you can imagine the scale. The command side, however, scales really well. What I can't say the same about the projection side, but we get back to projections later. So what I tried to do is that I wanted to keep my domain model intact. So this is my domain model. I want to keep it as it is. So I don't want to change anything, and I want to move to actor model. So how do I do that? And then I thought, yeah, look, I get away from the idea of that aggregate is an actor, but you know what? I have this flow, and the flow is there is a command, comes to the app service that calls an aggregate, produces the event, right? So this is the flow. Why do I need actor be an aggregate? Because it's a pure object. It can be a set of functions. It doesn't need to be anything. It has no references to any kind of infrastructure, and I want to keep it this way. So I say, okay, I make my actor an application. So how does it work? It works actually very nicely. So if I try to do the same diagram as I tried to draw before, so let's say I have an event command, and at the end I want to receive an event. That's my goal, right? So what happens is, in the long run, when the command is received, command contains the aggregate ID. So here is my actor. And actor, let's say it doesn't exist yet. So this is the first time I started the system. There's the first command that comes to the system. So what an actor does, first step is restore. So it goes to EventStore. Greetings to our sponsor. Sorry, that wasn't intentional. But it's awesome product. I use it a lot. So from a restore, it does the same. It reads the aggregate stream. And it applies the command, and it calls the aggregate. And aggregate emits event, and it gets persistent. So you say it's exactly the same with what happened before, but wait a second. So what is this? It's the second command coming from the same entity. So we have this command again. It comes to the actor, and we want an event, and there is this aggregate here. So actor already exists. It already has a state. And because the actor has a single mailbox and all messages there are ordered, you do nothing. You just have the state, you call your aggregate, and you produce an event. So there is a single write operation and no read operation, opposed to what happened here when especially in there. Every time we need to execute a command, we read. It actually makes the difference. So I built an EventStore system with actors using Proto Actor, a small framework in C#, and we were able to speed up significantly. We actually were able to run an actor system with a few 100,000 actors, and it shows when it spins up, when you start a system, it takes a little bit of time for it to catch up, to warm up. But because, again, you don't have a situation, normally you don't have a situation to receive 100,000 commands for a single entity. You usually have it spread across. Let's take vehicles that report some sensor data. They actually move around, and not all of them are moving at the same time. So it gives you, especially if you're around the globe, if you have in multiple time zones, you have a nice warm-up, the system catches up, and suddenly you have a system that consists of a lot of actors, as many entities that are actually reporting data or sending commands or events to you, and they never read anymore. They only write mutations in state. You see, another thing is that you not always need to write an event, because if the command means nothing for you, a command actually brings your entity to invalid state. You choose to ignore it, or you choose to raise an exception, which can be an event as well, but not necessarily. Sometimes you just say, I don't want this. This is especially interesting for telemetry. This is also interesting when commands deliver you exactly the same information as before. So in the traditional system, you would still... I never get rid. You will still need to read to understand what was there before. Is it the same as now? Do I need to do anything? Do I need to mutate the state? If you have states in memory in running actor, you don't do that. So basically, you eliminate, in some situations, you even eliminate significant amount of writes because you don't write anything. So So what happened with the idea of actors and aggregates? The problem that I had, and I tried to implement in Proto Actor, I tried to use Orleans, is that I don't really like to have my aggregates coupled to any kind of infrastructure. You don't start with actor model. You rarely, or never start with actor model. You start with that kind of model, or even more traditional model. You have your domain model that kind of being called by calling aggregate methods, and it produces events. That's what you have. And you don't really want to rebuild the whole thing because someone suddenly decided to put actors in that. So I did pretty simple thing, really. So if I look at this one, which is the actor-based, I can show you how that works. So I created a class that's called service actor, which is using the aggregate state as a type parameter. Nevertheless, what it does, this method just registers the store that we'll use, and when it gets started, it will say, I want to have a persistence with event sourcing, and I want to recover when I get started. That's all it does. And when it receives the message, that's Proto Actor API, it actually just calls the handler, and the handler is the application service. It's very similar to the application service that I had. So let's look at one example. So it's over here. So if I look at the vehicles, it's basically exactly the same as the application service. You can even move the application service around, so slightly refactor it if you have good abstractions behind. It's very easy to do, but it calls the domain model. It doesn't do anything else. The domain model stays exactly the same. It's the same class as I used before. So that made me that opened a way to actually, like, I choose that this application keeps using the normal event source system. This application potentially moves to the actor model. But I don't need to rewrite or create massive amount of code to support this. I don't need to touch my domain model. I can take it as it is and start using it. Because all my domain model does, it gets the state of the aggregate, and it produces events if it needs to, and controls the environment and stuff like that. So you save writes. And, well, I would say scaling in a traditional event source system is not a big deal if you just separate the read side from the write side, and you can scale the write side basically unlimitedly because it's not required any kind of ordering or stuff like that. It just receives commands, so it's not stateless per se, but it can be scaled horizontally. So if you run it in Kubernetes, you can easily spin up as many pods as you want, and it will just work. But it doesn't work like that for the read side. The read side is always an issue in terms of scaling, right? So let's look at how I build some projections. Here we go. So I have some of my projections. This is, for example, the vehicle projection. The projection, what it does is a very simple thing. So if I go back to the diagram, to the drawing board, so it gets an event, right? And it has somewhere it has the state, right? So it's an event has some IDs and some information. So what projection does, it goes to the database and does an update, right? So it's just update. If your database supports it, like in the book and in my previous version of this talk, I used the RavenDB, and it needs to read stuff before it actually can update things. Like in Mongo and in SQL, you can just run an update or delete or whatever else, or insert if you want to. You don't need to read. Usually when you receive events, your projections need to be idempotent, so you need to have a way to say, okay, I don't want to process this event twice, but at the same time, you need to model your events so they actually don't create any kind of side effects. Like if you process the same event twice in projection, it doesn't need to create invalid results. So for example, you avoid using increments, decrements, and updates on the existing values in the projection. You just write what you have. But sometimes you can't avoid that, so you need to read. The problem with projections is that they actually scale really badly, I have to say. So can you tell me why that? You all know event sourcing. I saw that. Are you all lied or you don't want to talk to me? You know why projections don't scale. And he knows. He's silent. All right, say something. All right, you don't want to talk to me. I knew that. So the thing is that we say, like, okay, we have this linear set of events, and let's say this is not the aggregate stream. This is the whole system in one single stream. So we call it the all stream, the mighty, almighty all stream in EventStore terminology, but of course in other systems it could be a Kafka partition, whatever else. It's still a partitioned all stream. It's an all stream for a side of the system that can be processed in isolation. So you can have in the read model over here or projection that reads different kind of events and skips some other. Why is doing that? Because it doesn't need to project those events, right? And these events don't necessarily belong to a single aggregate. They might come from a bunch of aggregates. And if you go a little bit overboard, we can even project events from other bound contexts. Saying that we build a new context called reporting context. What it does, it actually combines information. That's it. All right. But you see, if this is this event is saying that speed, I will use the vehicle example, equals 100, and this event says speed equals 300, and then you raise an alert, like, ooh, no, red color, please. So imagine your projection is scaled. So you run multiple instances of this thing. So it's over here. And they're kind of competing consumers in the messaging term. So this guy gets this one, and this guy gets this one. So this way. But somehow this guy protests this event first, and this one protests this event second because they're running independently. They have their own subscriptions. This is exactly what happens when people put read models fed from the message bus and the message broker. That's just a disaster waiting to happen. And if you have a RabbitMQ that serves for years and you always get messages in order, believe me, there will be one day when they come out of order if you have competing consumers. So that's why in EventStore documentation, if you run persistent subscriptions with competing consumers, you actually have it right there in documentation. Order is not guaranteed. In the projections, imagine this is the same entity. So you protect 300 and just being overridden by 100. So everything is fine. You have not seen it. You've probably seen it for a minute and then it's gone. So you have your read model that is not representing the reality. What use this read model has? Basically none, because it's completely out of sync with the entity itself. So not only the read model it is eventually consistent by definition, but it also becomes really bad because it doesn't show you what you want to see. So, and if you have billions of events, you really will have this issue because you start scaling your single read model or the database that serves the read model vertically because you have no other choice. And you will start scaling your projection vertically because it just needs more CPU, it needs more networking, it needs a faster database. And you end up in a situation when it was before microservices, like you have a huge thing that runs because we can't run it in parallel. We can't run multiple instances, and that's the problem. So what I try to do, and haven't been confirmed working, so it's for you to actually follow up, maybe give me some ideas. So if we have an event, and we have this actor model thing over here, and there are actors that subscribe to streams. Oh, yeah, sorry. Yeah, scroll up, yeah, right. Thank you. So let's call the subscriber. This is an actor. Every subscriber subscribes to a stream. It could be all stream or whatever else. Let's say this subscriber subscribes to the all stream. This is an actor. This one will be indeed sort of a point of failure. So this runs only in a single instance all the time because it needs to keep ordering. At the same time, it doesn't do any database operations, doesn't do any I/O. What a subscriber does, it sends the events further down, and it doesn't necessarily need to be in the same sort of application or service, because let's say this is the projection actor. So there can be a lot of boxes that represent individual read models. Each of them is a separate document. Like if think about Mongo, your read model is a document. It has an ID. If you, for example, want to have sensors you have a vehicle, and the vehicle has multiple sensors, you want to have a read model that shows the status of all sensors. Also, sensors can be aggregates in their own, so you want to combine this information. So in this case, you use vehicle ID as a document ID. It works nicely. What happens there is that this guy is actually writing to them because it knows their ID from the event, and it starts to route these events to individual actors that actually project things to their own state. And it happens exactly the same way. So basically, so let's say this is my projection actor. What it has is the state that it actually received from this on the start from the DB. So here comes the event. It's getting hot, really. So on the first run, it received the state from DB, and on any other events that it receives, it has the state already, so it doesn't need to read anything. It makes it very reliable, because if you have complex operations, you really need to check something. Because as I said, there are exceptions to the rule. You can do projections that are not really that important. So you apply your event to the state, and you can decide either you push the state back to the database every time you receive an event or not, because that actually becomes the choice. In a linear projection, that actually is completely stateless, always retrieve states, update states, and it does it for every event. It has no choice, because otherwise you just lose the information. The actor has this choice, because what they do on top of that is you can build an API that is consumer of the actor model, and the API will call your actor to retrieve the state instead of calling the database. The use case for that is not actually that broad, because in many systems, especially in the system that we tend to work, like boring line of business applications, it's probably not really applicable. But there are cases when this is really interesting. Because imagine that you have a fleet of vehicles, maybe 100,000 of them, and they all move. And you have a read model that represents their position on the map and maybe some sensor data. Again, the temperature, the speeds, altitudes, and stuff like that. So if you want to project every single event to the vehicle location or vehicle state and show it on the map when the user looks at it, you will end up in hell. Trust me, I've been there. So what happens is that you just can't process that massive amount of information that comes to you and just put it in a database, because basically if you're just starting up things, you experiment, maybe your database is not that big. We use like Mongo cluster M30 or something, it just couldn't keep up. But you know what, this read model information is transient, because what happens with vehicles over here, like if we have this, where was it? We have this bunch of events, and every event delivers delivers the new piece of information that overrides the previous one. if you have an API that goes directly to the actor and asks for this information, do you need to keep everything in database? Actually not, because who cares if you just don't save, if the information is delivered every minute, for example, that's not that frequent. Sometimes it's delivered every 5 seconds or even more frequently. So do you need to keep it? Or it's enough for you to store it once per minute or even once per 10 minutes in the database? Yeah, probably it is, because you basically, if you lose it, next time the vehicle will report, you will get it again. Even if your system gets down, you will get the latest state. It will be stale for just the exact amount of time that you choose not to save your data to the database. But a new event comes, it overrides it, and you have the new state. So you can actually have a flush interval. It can be either by time, or it can be by number of events that you processed, and then you decide, like, now and then, from here, so every second one, or like 1 hour, I will write back to DB. But all other events will be just projected in memory. I'm really sorry. It's supposed to actually follow me, but it doesn't. It doesn't like me. So maybe if I turn off the... Yeah. So you decide to flush it. So basically it becomes a buffered flush or something. So you change the state. You don't accumulate events. You actually process them, and you build an API, and you let it actually project, and you read using the API directly from the actor. There is one thing you can't do, or it's pretty hard to do, is basically run query on an actor system, because how the hell are you supposed to do that? Because what you have is that you have a bunch of actors, and every of these actors is identified by the ID. So you don't have an index. Either you build an index actor that does it for you, you keep sort of a repository of them, but you need to get it updated. So it's pretty hard. I wouldn't do that. So for that reason, I would say that keeping information in database is still useful. You just need it in order to run queries, but to retrieve individual read model, you might use the actor as well. So I actually built something like that in here, but I'm pretty sure it doesn't work, so just don't blame me for that. This is the read model. This is the Proto Actor thing, and this is the... no, I can't show it. I can show it on the screen. All right, close this one and say... Can you see it now? You can't see it. Can you see it now? So basically the projection also looks exactly the same. And this one uses snapshotting. So this is why I actually don't write every time. I use the integrated thing in Proto Actor. So I have a snapshotting strategy, so it doesn't persist every time. It just uses snapshots. And the read model looks exactly the same as before. It's the same document model. And this is the projection. It also looks exactly the same. So it was very little for me to do in order to make it work, except that I need to take care of the projection actor. The projection actor is a bit of a hassle, but I want to show you one thing, which is the projection actor. Yeah, it's also not very big. So basically, it looks very similar to the projection. The only thing that I kind of didn't do properly is that I think all my actors process all events, so it was not the idea, and I really wanted to be isolated to one single document. So the final thing that I want to say is that what happens with the system, where is my mirror? Here. All right. So what happens if you have this all kind of done, how it looks like? How it looks like in the infrastructure deployment. So let's say you have an API for commands via CQRS, right? And we have the API for queries. They're completely isolated. They can be hosted in different processes and stuff like that. I'm really sorry about that. So the API is the client of, so that it has some sort of way to talk to the actor model. The actor model consists of a lot of services, or it's the same service, but it actually can be spinned up in many, many, many instances. And they all form a cluster. And here is the same, except of here you will need to have a subscriptions as well. So what happens is that the commands go to individual actors, and this is the cluster. These are not actors. These are instances of the application that run the command side, and they have a lot of small things which are actors. And the cluster self-balances itself, so it actually distributes the load across as many instances you have. And if you want to have more instances, you just say, okay, I have one more. So you literally go to go to Rancher and say one more, please. Or if you use JKey, whatever else. And then the cluster redistributes. So if you spin up a new instance here, it will actually put some actors from here, from here, and from here. And they will rebalance. And then they will all update the routing. And when you send a command to the actor system, it will be processed by any instance. You don't really know which one is. So the command comes and comes to some of those places and talk to the actor. It produces an event. It puts it to EventStore. Produces events, puts in EventStore. Events come to the subscriber. And subscriber distributes the work over here. And then you have APIs that read from those actors that run in the read side actor model. So I've done this part. And it works splendidly, especially with the ability to sort of buffer our state updates and stuff like that. We also have done a couple of these things. So in one application, we have events that we don't really need to project every time. We project now and then. So, and we have an API that talks to the actor model. But you need to have a reliable clustering system. So if you ask me about implementation, I would say, yeah, I tried Proto Actor. They use console for clustering. It's not that reliable, in my opinion. So I had some glitches, and I still try to figure out how to deploy it properly in Kubernetes. But I think it will be better somewhere maybe between now and maybe beginning of next year, because we need to move forward and migrate to .NET Core 3 and stuff like that. There are probably not that many .NET developers here. Or how many are you here doing .NET? Oh, that's different from my usual audience. But nevertheless, so I know that in JVM you have, of course, Akka. You can use Akka.NET, whatever. In Akka.NET, I find the API a bit awkward. In Microsoft world, we have something built by, or in .NET world, we have something built by Microsoft, Orleans, which is rather slow, but still does the work. But it's really nice to experiment with that stuff and try to do things a little bit different. I think actors give you a very good way to isolate the things, but in general, what I try to, my message is that don't try to bring the infrastructure stuff to your aggregates. Don't try to build your aggregate as an actor. Don't even think about that. Your domain model needs to be pure as you can. and then you just try to move on if you feel a need for it, if you feel a need that you have massive scale, you have a lot of things going on, and you want to be able to like just click a button and spin up a new instance and it will run, then probably you want to try it out. And I will be continuing this journey, and if you have any input or you have any interesting things to discuss, especially on the read side, I'm very curious about that. I never got it to work because I just didn't have time and really didn't have the need, although we have some similar work in production. So yeah, talk to me. I'm available on Twitter. Just ping me and we'll have a chat or hang out here in the hall or after the conference. Okay, I think that's all. I'm out of time. No, not really. I actually had 10 minutes stolen of my time. I have some code running. I don't know if it's really interesting for you guys and girls. Let me see. So I was doing the my stuff is running here. I use Rancher just for sake of showing things, and all of them are running in Kubernetes. All this stuff that I've done is like spinning up new instances, things like that. So what I wanted to show, but I don't really have time, is that the read model really sucks when I scale it up like this. So it will actually get real issues. Command side doesn't. So I have quite a lot of code in my repos. It's right now it's a private GitLab. It's mine, my own, my precious. But I'm going to push it back to GitHub as soon as I'm done with the infrastructure wiring and stuff like that. So all this code is available, but since there are not that many C# developers here, probably it's not that interesting for you. But still, I mean, if you use Java, it may be very similar. So questions? $100,000 actors is about it's for like okay for a system that processes about 5-6 billion messages per month, and it has 250,000 running actors roughly. We use 6 pods, 1 gigabyte, and RAM and 1 CPU. So it's not much actually. The actor model doesn't induce a lot of additional sort of concerns about the. So there is no that much complexity that is technical attached to it. So it's a little bit of wiring, but yes, I understand your concern. It's like the memory thing, right? Right. So it's. But remember, the actors don't run all the time. They sit and wait until the message comes, and then they spin up. But they keep state in memory. So you need to count that your state fits in memory. So, and you have like an actor system, 1 billion actors, but they don't do anything. So you don't need any CPU, but you need a lot of memory. Yeah, sure. Thank you. Hey man, how are you doing? There is no sound in this room.